again, because Paul, Professor Paul just told me this one. So last week I just this week we just talking about the science of powder MI field, but not only in MI, in PM, AM, metal A is metal additive preparation, 3D printing. Also use this tool. Okay, so we just check this is last week. So we made a video and MI was plastic only. I have a video picture and the visuals and its property or something. We just talking about this contamination process. Okay, so I forget about translate the total file to a professional team. So today after this classes, everybody should be asking copy the file to your computer, then you can review. Okay, so today we're talking about the powder. Okay, so ideally this is a powder. Am I right? Is this powder? This one is powder? No. Why? Why?
It's not like powder.
This is not like powder, yeah, because its dimension is too big.
Yes.
Yeah. What is MIM powder size? Mesma. Do you remember?
30 micron.
Okay, 30 micron. That's right. Okay. So this one just a shape like the powder. So today we're just talking about the science. The first one, shape and the geometry appearance of the powder. Okay, we just describing the powder, and we just talking about the particle size of the relative powder. Yeah, this one we make up the way. Okay. So this is a very interesting samples. What we're talking about this one. And then we're just talking about a very important parameter. This one is oversized string diffrater. This means AB oversized string diffrater. We design a parts like this one. For example, this is our main part, finished main part. We have a drawing to make this one. Okay, so when we make this one drawing, we needed to make a mold to inject in this one. But how big is we needed to oversize to biggest, because this one is with mixing powder and the binder together. So we needed about we call this one OSF. This means the green part is bigger than this one. So you should remember every process we need to make a material safe concept. Material safe, or in English somebody will say steel safe. That's in casting process. You know casting? Melting the metal and put on the sand mold, casting. Every casting process, every forming process, we need to make a safe materials, because if we change it too much, it will small. When it is small, this will fail. But if this one is bigger or something is big, we can modify, we can rework it again, then approach it. Correct application. So this one is very important. Okay, this is in English. In Chinese, we call this one as So somebody will say here, set. Okay, this is an important foreign technology concept. So if next time you meet this word, you just understand. Yeah. So much purchase should be made a little bit. Yeah. Then after we get this green part, we can do the post process. For example, machining, grounding, polish or something. This one dimension should be smaller and approach your drawing spec. So you're just thinking about our drawing define the spec. Then your parts should be closing your drawing. That's very important. Okay. Okay. Then finally we will talking about the rest of your MI pistol. Okay. This one can take money. Hello? If you want to get money in Indonesia in the future, you actually can go back and make an MI factory. Okay, then this one can get money. Yeah, this is really interesting. Okay, so today just talking about the powder module size. Okay. Okay. Who is this? Who is this? Buddha. Okay. Buddha said, one said, one word. What mean? It means if the particle is very big, bigger than like the Earth, okay, is a word. So depend on your scale. When you watch, when you looking at things, just thinking about the scale. Scale is very important. When you use a micro scale to watch this world is very giant, very big. But if we go to the nano, we go to the small and nano atomic grade, okay, you can find different words. Okay, so Buddha says, one said, one word, okay? So infinity and uncountable, like I said, in the Ganges River. This is India. This is river in India. Okay. And the powder technology are many little making. This means college very small things, then together become a very big materials or very big parts. Okay. Just like you do everything, we do everything. Okay, many people together, then you can get a successful business. Okay, so this is very important. Our words until like fortress. Okay, remember this sentence. Okay, and this unit in the Buddha and 佛经什么的，圣经 Bible, like the Buddha Bible say. Okay, the unit is one closer and common 16 grade is very big. Okay, so today we just talking about basically about the science. It's very easy. We not discussion very deep, but surely understand this one. Okay, we have a brain works. We should be understand what kind of mathematics and physical we use. The first one we call about the scale, and we know scale, then we can calculate the area and the volume, and we need to know the coordination numbers, and we need to know the dimension and the gravity. And number 4 is a spatial surface area, and number 6 is our source, where how we can get the powder, and number 7 is how to make a powder problem forming way. Okay. Okay. The first is very easy. Okay. We define if one particle is smaller than 100 micron. So the 100 micron, smaller than 100 micron, we call this one is powder. If bigger than 100 micron, 100 micron, we can call this one is particle. Okay, but particle also is including powders. Okay, so we just like this one. In English, it's this one. In Chinese, we call this粉末. But somebody will say 粉体. Okay, so in English, you just one word. But in Chinese, many talking about this one. Okay, so we can check this one. So this one is 100 microns. So we're just talking about hair. Our hairs, the dimension is about 100 to 150. Okay, if your hair is like a spring. Okay, this means your cross section is more big. This is not a circle. Your hair cross section is like this one. So you spring. But if there is thread, okay, the cross section also is a circle. Okay. So because this one is dimensions. Okay. Then this is a PM powder. It's a range just like 150 to 70 microns. Okay. And this is AM. AM is an additive manufacturer. Okay. Normally we call this one additive. And this one is mean. So mean range is in 0.5 micron, bigger than 0.5 micron, and then approach about 30 microns. Okay. This is thin. What is thin? Thin is ceramic. Ceramic. Okay. Ceramic is what is ceramic? When you eat the meal, 碗, 陶瓷. So ceramic is 陶瓷. And the ceramic and the ceramic is different. The same materials, but its purity is different. High purity we call it ceramic. Low purity we call it ceramic. Okay. Okay. Then this is PVT. This is a physical evaluation deposition film. It's coating film. Okay, this is semiconductor process. So if in the future you get a graduate from NTUSD, yeah, you will where you want to go. NTSC 台积电. Okay, then you should be understand these applications. Okay, and this one is COVID-19 virus. Okay, this is dimension 92. And this is mercury, this is atomic, and this is quantum. Okay, so small. So our size range just like 0.1 micron to 100 micron. And I remember last week you asked me the zirconia powder. Take care. When powder is small, it's more dangerous and more difficult for forming. And more dangerous. Why? Because when powder is small, can fly. Every small powder, if it can burn, it will explode during air. So very dangerous. In the other hand, for example, the oxide is small, not so dangerous, but when you go into your system, you will sick. So everything should be remembered. The small size is so dangerous, it should be controlled. Okay? Okay. So any question, just ask me if you have a problem. And the team just say, okay, you can go to talking about with Dr. Kim. Okay, it's very important. Okay, so we know this one scale. So this one we say is micron, and this one we say is submicron. Submicron is a nanometer. Yeah, nanometer. So this is very small, But when the scale is changing to small, everything is different, like a build, like a build materials. So different dimensions will make decision your process easier or not. So we just need a scale. So the first one is powder size. Powder size. First is scale. You should remember. Okay. So this is a ball. It's easy to understand. This is a cubic. Understand? So easier in mathematics and physical. You can understand. When you are in junior high school, in junior school, you just every day just calculate mathematics. Right here. So it's a edge. We call it one is A. So the AV, this is because this one is cubic. So the AV surface, AV side is the same. It's A squared. Okay. So this total one square. The side edge total is 4A. Okay. Easier and cubic is A3. A cubic. Okay, then this one, the volume is A3. This right. So this there I make a mistake. Okay. So in a circle, the dimension is D. Diameter is D, and it's a circle area is pi and D squared over the 4. This one understand easy. Okay, and this is a circle length of the circle. Okay, 2 pi t. And this is a volume. Okay, this one. Okay, and this one is a ball surface. Okay, why we need to understand this one? Okay, it's very interesting. Here is a sample for a powder, like a powder. But this one, we're just thinking about this one is just a 30 micron. Okay, this is a big ball. Yeah. Okay. Then when the ball is rolling, okay, we can. Do you know where he will stop? Where? Easy to understand. Easy to make decision where it can stop. No, not easy. Yeah. But when the powder is changing its shape, okay, this one is a different shape. Okay. So okay, it cannot go very long and easy to understand where they will go. If the changing shape is different, it's a direction, you can understand, to easy to control. So most of people just talking about the powder should be like a ball. This one is much good. Just like you would say, you want a ball. Why you want a ball? Because you need easy to control the size, easy to calculation. But the process maybe should be understood. Okay? And very interesting. When this powder is forming and finally it broken, or this one is empty, hollow inside, it's broken. Okay, how many pieces we don't know, and the quality will change. So this is the powder forming technology problem. So everybody should understand. But easier is powder size is too small, and its strength is good enough, not easy to work. Okay, this is we are lucky. Okay, wait a moment, we'll do this one again. Okay, so we will say, okay, this is a square, so we thinking about this one as a mold. We just input the powder because normally powder is like a circle. We want like a ball, like a circle, easy to use. So in 2D, just a 2D, we fill in powder the dimension is same. So what is the property of this area of the circle in a square? So this one D equal to A. So this one inside that's only 78, 54%. Okay? Okay, this is 1A. So if D equals to 2A, it means small square. So we can put into, okay. So very interesting. This dual is true. Okay, the powder size, even the square, even the circle, they is good. This is mean you use this kind of shape, input the mold, it just can fill in about 78% close. This is 2D. Okay, how about 3D? Okay, we change. Okay, the same. Then we make it calculation. Okay, we make it calculation. Okay, so we gather this one. This is model cube. This is model of ball. Okay, so after this one, then just synchronize. Then we got 34%. This means we can fill in cubic this ball. So we make the ball small, but every ball is the same size. We just fill it in, and the simple staking, we just get the same rules, even the powder small, the same dimensions. Interesting. Yeah. So how to increase this one? How to increase this one? Make different dimensions of pole. Okay, so it is easy. Okay, everybody can understand. Okay, this empty we can put a small size, not big size. Okay, so this is the powder size. Very interesting. Okay. So the mathematics is in the four circle in the center, how much the dimensions biggest? So you can calculate it. How to calculate it? Yeah, just draw in. Okay. Draw in. Okay. Then this is 2A. Okay, this one is so this is easy to understand. We don't need this one will not make a test for you. Yeah, there's no use. I just want you understand. Ever since we can use the mathematics because this is a tool we can understand its principle. We can understand everything basically. So you just because now computer science is very good. It's just easier to understand everything. You don't need to spend too much time to calculate this one, but you should be understand. This one is why we need to learn mathematics. 1 and 1 equal 2, but in computer, 1 and 1 is 0. Am I right? Yeah, it depends on your different logic. Okay? Okay, so this one is a four circuit in the center, the maximum circuit is 1. And this one is 3, maximum 1. Okay, this is 2D. Then the 3D, okay. In the 3D, there's so many kind of state. So in the material science, we have many atomic calculation. This one is a simple cubic. This means every corner we put down the ball. Am I right? So every corner we have a square. How many corners? How many corners? Corners. How many? One square. How many corners? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Right. So every corner has a one ball, but just only one corner. Yes, that's right. So this means in this circle, how many balls inside? 2 or 1? 2. Yeah, because this one is 1, 2, 3, 4 is 1, and 1, 2, 3, 4 is 2. Okay, this is material science. We're just talking about the atomic structures. We make this one calculation. Very interesting. Okay, so if we want the improvement is boron percentage, we just need to put a small size ball inside. So we will discuss how many ball we can input small size. So now just know this one just 52.3% boron of the ball. Okay, so next. So this one is different, just BCC. We just remember SC and BCC, body central cubic. Body central cubic is we put one ball in the middle. The other side just put again 1, 2, 3, 4, 5, 6, 7, 8 corner, and total is 3 balls. Okay, total is 2 balls, 3 balls. So this one is 3 balls. Okay, so this one is 1 ball, just 1 ball. Okay, don't forget, not 2 balls, 1 ball, because this one is a quarter half. Okay, so it's 1 ball. Okay, and this one is in the center we put down. So the difference is this one is a triangle. This here to here. Okay, so you can calculate this one, and we can know the size. So totally is the voltage is higher than 16. Okay, 16A. And this one, we call this one phase cubic, phase central cubic. Okay, we put down the powder in the side. So we have 6 sides. 1, 2, 3, 4, 6. But we have 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. So totally how many balls? How many balls? The side, we just know only 1. And the 6th surface has just a little pointer ball. So total is 4 balls. Okay, so this is up to 74%. Okay, this is interesting physics. Okay. And number 3, we're just talking about coordination numbers. It means one powder touch how many powders. Okay, so in 2D, the A, powder A, how many pieces can touch in this simple cubic? How many? One ball, one circle just can touch 4. B. This one no touch, so we just say this A is a coordination number is 4. Okay. And but this is 4, but this one is more. This one is 6. So depend on its arrangement well. Okay, so different. Okay. So we just make the coordinate numbers of the 3D space. Okay, we just understand the simple cubic. This is the body central cubic. This is the face central cubic. So the coordination is different. This one only 6. One ball is a cubic 6. This one can touch the 8. This one can touch the 12. So this means if any powder, if any process, we need to increase the density of the powder. Your coordination should be higher. Your density will be high. Okay, understand? So this we just talking about the percentage. So in normally, in random way, we just put down the powder. Any kind of powder, we just put down in the cubic. Okay. The first one is it should be smaller than 30 microns. Okay, input. Okay, normally we can approach this one, no problem. But if we want to up to here or here, you should be made so many ways to increase. Okay， 所以你要的球形粉末问题会有很多，就是这样子。Okay, so this is interesting. Yeah, because everyone is circular. Okay, 我知道了。好，所以 understand. So this is easy to let you understand. Any powder, if you want to state it more, the coordination number should be higher, and you can change the diameter. You just cannot keep it one diameter. Okay. Do you think if you buy a powder just only one diameter, is it expensive or cheap? Cheaper or expensive?
Expensive.
Why? Why? Why?
Because I need more powder.
Yeah, you need more power to mesh, to make it inspection, to make it check. Yeah, everyone should be same dimension. So every piece you need to know. So you need a machining, you need a mesh, you need to check again. So random powder is more cheap, and the uniform powder is very expensive. So when your dimension, your tolerance is small, the cost will be higher and higher. Okay, remember. So when you buy the small powder, very interesting. Most of powder has a different price and the different dimensions. For example, the ceramic, you very difficult to buy the 10 micron ceramic. Why? Because of the bigger powder for the ceramic, the powder only less than 1 micron. Most of powder less than 1 micron. If we want to say, oh, Dr. Q, I want to buy the 10 microns. Okay, one piece. How much money you need to pay for me? I don't know. It's very expensive. But metal, we just can make a big. So it is a difference. Okay. Okay. This is for in American school. I cannot remember this one is MIT or not. Okay, you just go into school, make an examination. The professor just say, hey, you want to go inside? Come on, list this one and the calculation it for me. Okay, so this is calculation. Just asking how much size, put put one ball inside. The biggest diameter is 1. Okay. So this we just calculation this one. We just know here. So total is this. You don't need to make. Just understand. Okay. Because you are going to the NTUSD, you cannot go anywhere. You just stay here. Okay. Okay. This one is not much easier. But this one is difficult. It's a triangle. We just put down inside. And this 1, 2, 3, 4, there is space. You need to calculate this way. The ball is more difficult. So here is mathematical solution logic. We just are thinking about. Okay. Okay. And Tim Chan just said, Professor Tim just said, okay, this one will not make a calculation for you. Okay. It's very difficult. We just understand. Okay. And in the fourth topic is dimension specific gravity. This one is a specific gravity without any unit. Okay, because this is we just compare 4 degree C water and your material density comparison, and we get this one. So this one is non-unit without unit. Okay, then this one is within unit. Last week we just talked about this one. Rho equal to mass and the volume. Okay, and when you check the parts is okay or not, the first you will check about is quickly weight. Yeah, because weight more easy. If you want to make a dimension and the calculation is moment, you use the meter is very difficult. So we will use the Archimedes principle. We use put in the water, then we can know this volume, how much volume. Okay, so we just from here. Okay, so if you know this one, you can know okay, but normally if this one is cubic, we just need to understand this is x equals y equals z. S equal to f, y equal to z. So the total is s cubic. Okay, so this one is very easier to understand. But everything is from here. The m most like this one. This is very simple equation. Everybody should remember this one. You can use one life, your life, my life, also the other people's life. We just use the same equations. Very interesting. Okay. Okay. Then this machine is tapping density. What's the tapping density? This means we input the powder inside. Then the powder has so many spacemen. So we just shake it, tapping. So the powder will stay together more high density. Okay. And we just use this test, for example, 3,000 taps or 10,000 taps, and then to make it prompt, make it this numbers. Just talking about tap density is this one. Okay. So this you just remember this one is very easy, but should be know this one. Okay. Next, okay. Now we have 3 colors cubic. Okay. The gray, the red, and the yellow. Okay. Here is just expressing the particle size and the surface area different. Okay. The total volume is the same or not? Total volume. The gray is 10 plus 10%, 1,000. Yeah. The red also is 1,000, but he has a separate. Okay, so it's a total is 1, 2, 3, 4, 5, 6, 8. 8 pieces, but the total volume is same. Okay, and this one is total is 64. Yeah, because close one, cut one, and cut one again, just a half. Cut one again. So every piece is different. So the volume A and the volume B total and the volume C total is the same. 1,000. But what is increased? Surface is increased. Okay, because it's easier. This one is a 6 side, 6 face. So we just 10 plus 10 is the area, then plus 6, 1 block. So total is 600 unit square. Okay, a unit meter. You need the okay, then this is the area. It's 5 plus 5 and 6. 5 plus 5 and 6 side, but totally is 8 blocks. So this one is 1,200. Okay, then this the C is totally okay. So it's they are just make 4 different. Okay. So interest is when teacher team just asking somebody say, okay, we have one tank painting, one tank painter. Which one will spend more paint if the every paint the same thickness is the same? Which one is more need to use more paint? Which one? Which color is need more? Yellow. Yeah. So the surface is small. So it means when particle size, when powder size is small, its surface is increased. Am I right? So if the surface is increased during the process, it's easy enough. Easy enough. During the process, because the powder, okay, you just translate one powder or translate some powder, which one you easy to translate? Just only one is easy. It's one piece, okay, approach. And you need transport 1,000 piece. You need again. So this means fresh force is increased. So when powder is small, friction force will be increased. So increase friction force, what will increase? Temperature will be high. So during the process, if your process even control the temperature at 25 degrees, but just one ball go there, no problem. Or just a solid ball go there, everybody will be heating. Every powder will heating himself. Everybody heating. The powder temperature will higher. The process temperature should be higher. So if the temperature over the melting point of the powder, your process is not is particle forming, it's a liquid side, liquid phase forming is different. So should remember this one. So the second surface from here. Okay. So now you can know the fine powder is not good things. Yeah. So just remember, we MIM just use the 13 micro, below the 13 micro powders. So small powder may be not good, but powder size is small. Your surface condition will be good, more smoothing after sinter. But your process will be not easy to control. So just remember this one. Okay. Okay. So this is a test of you. 1 gram, 3168. 3168. If the powder is 10 micron, one piece is 10 micron. How many pieces in 1 gram? Okay. So the first time you need to know this equation. Okay, this is Bourne equation. This is rho, okay, density. Okay, then everybody know the 3168 is the dimension, still dimension 7.9. Okay, this one is you can check by website. Okay, okay, in website. Okay, open website just told me CNS 316L. How many is density? 316L. Google. How many is? Okay, so depend on your calculation. If you binder from the website, okay, we can make the same standards, no problem. But in MI, we normally use the 7.9. Why? Because after system, just a little closer design, so we just call this one. Okay, no problem, depending on your reference. Okay, so every kind of materials we can find density in website. Okay, for me, 74 pH. 74 pH students. What is density? 74 pH. How many dimensions? Okay, so you can watch the 316L, you can watch the 304, you can watch another couple of. Okay, a lot of numbers and text assembly, or this we call this one is standard materials brand. So you just to understand, then to touch this one, you can know its competition, its normally numbers, we call this one. Okay, so you can check this one. Okay, for example, this one is a 7.9 kilometer cubic centimeter cubic. Okay, so totally is we can make an assumption is 20 micron, 50 micron, 10 micron, 8 micron, and 6 micron. Okay, so different powder size. When the size is small, the quantity will be increased. Okay, so this is different. Okay, my God, I never had too much money here. If you have money like this one, when you become rich, you don't need to study here. So you just study here is want to learn the numbers. Yeah. So the every specification service area just okay, this one is very important. Just remember, scale is small, surface will increase. The process is different. You should be take care. Just like you in the future your test. You want to use zirconia powder, always 0.3 to 0.5 micron, one piece. Then you want to add to the metal. The metal powder is about 17 to 16 microns. It means 100 times. Then you will meet another problem. Yeah, because how do you make the powder, zirconia powder, very uniform in metal powder? This is the first problem. Yeah, so you have need to know how to make this one. We say we make the feedstock is very different. Okay? So, okay, let's we take a break about 12 minutes. Now it's 2:18. We go back here to 30. Okay?